So we're going to be talking about the direct product again today. So if you haven't seen the video on the direct product, or you just don't know what it is in general, then be sure to look that up before you come to this video, because we're just going to be talking about the property. So it's a direct product of two groups, G and H. The order of this group, right? So the amount of elements in it is equal to the order of G multiplied by the order of H. And if we think about this, if you think about how any element in G, direct product H, looks like this, with G's in G and H's in H. For a fixed G, there are order of H possible combinations of H, and for fixed H, there are the order of G possible combinations of G. So the possible amount of combinations of little g and little h in this bracket are the order of G multiplied by the order of H. Okay, so hopefully that makes sense. Now we're going to talk about the order of the elements themselves. So if GH is in the direct product of G and H, and the modulus, the order of G, and the order of little g, little h, is finite. Okay, so they're not of infinite order. Then the order of the element, little g, little h, is equal to the lowest common multiple of the order of little g and the order of little h. And why is this? Because if you think about the definition of the order of an element, it's the amount of times we have to apply the binary operation to get to the identity. So the order of G gets us to the identity in G, the order of H gets us to the identity in H. To have an identity in the direct product, we need the identity element of the direct product, the identity in G, the identity in H. So if we just take, so the lowest common multiple is the smallest number such that it's a multiple of both the order of G and the order of H, and that means that this will be the first time that we'll get this double identity. Okay, there'll be times before that where we just get E of G appearing but not E of H. There might be another time where we get E of H but not E of G. But the lowest common multiple is the first time these both appear, and that's the order. Okay, and the final fact, we're not really going to talk about too much, but I encourage you to take a look at it yourself. If you remember what abelian groups are, so G, direct product H, is abelian if and only if G and H are abelian. So I encourage you to think about this. If you remember, this if and only if means that if the direct product of G and H is abelian, this tells us that G and H are abelian. And if G and H are abelian, this tells us that G direct product H is abelian. Okay. So these are identical statements. That's all we're going to look at in this video. I encourage you to try and prove for yourself that this is a result of that, the direct product being abelian, just using the definition of abelian group, which we did cover in an earlier video. If you do have any questions on this, or you need sort of some tips on how to start this last little proof, let me know that in the comments. But for now, that is it. If you did enjoy the video, please be sure to like and subscribe, and I hope to see you in the next one. Thanks for watching.